Hey developers, this is Leela. Welcome to my channel. In today's video, what we will try to do is we are diving deep into one of the most powerful feature of the Node.js. That is nothing but the writable streams. We are trying to learn about that one also. That's common first knowledge you're learning. So this is not the basics thing. So the previous videos all I have completed all the basics. Now we will look on how to handle the back pressure using the drain event properly and understand the significance of this high watermark. So with our experience, so by the end of this video, you will know how to write the streams efficiently without choking your memory. And yes, with real code example, I will try to show you the benchmark and also the tips from the official docs also I will try to show you. So fine. Here we have learned about the basics of this one, all the stream, right, and the drain event. These are all the things we have learned it, right? I will comment out this entire code, okay? Or otherwise I will delete this entire code. Yeah. So now we need to target or we need to focus on this for loop. So which we will be writing something like half a billion or half a million. I don't know. So 5 million. Let's say that. So 5 million. I think. Yeah. Let's try to see. Yeah. We'll try to see the benchmark of this progress. We'll see it. So now we are trying to do this one. So now when you are writing a huge amount of data to a file using a writable stream like a million entries or anything, so you might be tempted to just go for in a big loop. So like this we will try to go it in a big loop, but there is a catch. This fills up the Node.js internal stream buffer causing the back pressure, which we have seen it. So this is the thing which we have seen it. Memory bloat and also the serious performance issues you will be able to see it. So that is nothing but this is the best example. So here we are not trying to handle the back pressure. So that means here the stream will have an internal buffer of around 16 KB and we are not taking it and we are going on writing the data into the stream so that the memory will go out. So that's a bad practice which we have discussed in our earlier videos. So this might look fine at the first, but if you monitor your memory usage, it could shoot up to 200 MB or more. So which we have already seen about this one. So fine. So then what is the right way? So we should handle the back pressure. First of all, we should break the loop when the stream.write return false. So when the stream.write returns false, we should break the loop and resume it only when the stream buffer drains. So that is the main thing. So now for this one, we need to refactor this code. So let's try to refactor this code. First of all, we will define our loop inside a function so that we can pass and resume it later. So for this one, what I will try to do it is, I will try to create another method. So that is nothing but write many. So in this one, I will try to copy this entire code and I will try to move it to this one. So this is the thing. And the next one, what I will try to do it is, I will convert this for loop into a while loop. And also I don't want to initialize the variable here. I want to make it as a global variable so that I can resume the loop from that I value. So here I will be taking and I will change it to while loop here and we can remove this one and I can use this I++ also cannot, we will not do it, I less than like this and we will be await file handle.write. I am removing this one. So we are creating the buffer and writing it. So fine. Okay. So this is one thing. So now we have created a write many function and set up let's try to set up the drain event also. So let's try to set up the drain event. So here I will write stream.on drain. Okay. And here I will be writing. Then I will call this write many. Okay. So now when the drain is completed, we will be calling this write many. So resume from where we have left off. So now what we need to do here. So we need to know that here we need to do the I++. So here I will be doing the I++ after writing it into the buffer. Fine. So if the stream is not there, okay, if the stream is not there, then I should have to break the loop. Okay. So if it returns false means I should break the loop. And then afterwards again, it should write it. That is one thing. Okay. So now when you run this one version, so memory usage stays around 50 MB with a huge environment like this. So let's try to see the output for this one. I too don't know. So let's try to write here. So it has finished in 12.4. Okay, that is not correct actually. Let's try to see how much memory it will be taking. Let's go to the activity monitor. So here I will be writing this. I will be having it here. So immediately it is completing. So here you are having units, tens, hundreds, thousands, 10,000 lakhs, 10 lakhs, 500,000 you are having, but it is completing very fast. Okay, it back end. So let's try to write it another one, and here I will do. So that that one leave it, and here if I try to go into this one, why this one is taking, okay, my mistake. So I am not calling this write many function, so I need to initialize this write many function, right? Okay, let's try to decrease this one, so it will not finish this much fast. So first of all I need to jumpstart that I need to call that function at the starting. Now let's see if it will go. So 20 that leave it. So now it's Node.js is running. If you try to see here, the memory usage is not going more than 50 MB. So it is around 38 MB, something 40 MB it is taking. Hardly it will take around 50 MB. So now, so we are able to mention this one. So we need to know about this console.timeEnd also. So how we can benchmark this? Okay, it is taking some time. So maybe it's 500,000, right? It will take some time. So fine. So now how we can know? So the final one, how we can know it? So for that one, what we need to do it is when the stream is ended. So now it has been finished. So now we are able to 22 milliseconds. Okay, fine. That maximum this execution time depends on the CPU thing. So now what I want to do it is, so here if buffer I++ is done, okay, and here I can write it. If I is equal to so this one -1. So if it is in the last time, so the last loop if it is saying is I want to close the stream. So here I can do something like return stream.end of, and this end will take the buffer. So this is the last write, it will take it. Okay, so now you can also implement this one. So if it is less than something -1 means we can end the stream also. So what's happened when we are in the last write means we just don't stop, we end the stream properly. And the .end method also emits a finish event. So when you are emitting the when this end method is called, so it will emit a finish event, which is a perfect place to measure the execution time and clean up the resources. So here what I can do it is, here I can use stream.on/off finish off, and here it will emit the finish. So here I can do the console.timeEnd. So what it is trying to do it, that console.timeEnd, I will try to use it here. And what I can do it is, so now here if you want to close it means I can close the file handle also, file handle.close, that's it. So now we have made it. Now let's try to see this one, let's try to execute this one, how much time it will take. So let's try to see, this is the proper time. So now if you try to see it, the memory, the activity manager, the memory, we need to check it. So it is, the memory is not boosting, and also the CPU also it is not taking. So this is the perfect way how we will be writing the code. Okay, it will take some time depending on the resources of the system, the cores what I am having and all those things, and the processes, what are the processes it is running in the backside. So depending on that one, it may take some time, but in your system it will not take too much time. So here it will be finished it very fast. So let's try to see it. It depends. So now how many the value will be, so how much the value will be, the resources will be utilized less only. That is the main thing. Now if you try to see the code for the memory for this one, it is around 42,861. Let's say I will try to decrease one value for this one, or otherwise let's say that how many times it has been drained, we need to know it, right, as it takes. So how many times it has been drained means, so here I can take something like, let j is equal to 1, and here I can do something like j ++, okay, and I can do console.log of j. So we can print this one. Let's see how many times the thing has been drained. If I try to write it here, so it is going on, so these many times it is draining. Let's see whether the number value it is same or not. Let's try to see it. So these many times it is draining. Actually maybe the value is too much big. I think we can decrease the value. Let's see this one, how much time it will drain. Oh, this one is too much, so we'll try to make it with a smaller number. Okay, fine. Now if I try to run this one again, so now it will take around how many things we'll try to see. So now it has taken around 237 drain. So that means the drain thing has been done 237 times. Let's try to see the file size of this one. The file size of this one is around 3798. If I try to see the how many bytes it has been there, it is around 38,890 bytes or something like this. I don't know which one we need to take it. Let me know in the comments. So which one is the correct size? So I am taking 200 something like that. Let's go to the calculator. Okay, and I will paste it this one. And we know that the highest watermark value, the writable high watermark value is 16,384. So I will divide it with 16,384. If I do is equal to, it is coming around 237.5. So which is exactly matching with the value 237, and 238 has not came way because the buffer is not full. So half of the buffer is only full. So that's why the drain event has not been filed. Some of the data has been left. So this is how you can benchmark. So now, so there are around 237 drains we are having. So now high watermark is basically the size of the stream's internal buffer. If your chunk size exceeds, you will get a back pressure, and that's when stream.write return false. So that is the main thing. So when you call the stream.end, you can't write anymore. Trying to do so, it will try to throw an error. So that is very important thing you need to do. So if you didn't return it here, so then means you are ending the stream, and again you are trying to write it here. So then you may get an error here. Let's see. So you may get an error. Why? Because after ending the stream you cannot write it. Maybe at see here you may able to get it. Why? Because stream write after end. So here you need to must and should you need to return here. That's it. So that is one important bonus which I want to tell you. So now let's try to summarize everything what we have learned. Keep your loop inside a function. Okay, so we have kept the loop inside a function, and we have moved the loop index I outside the function to preserve the state. So we have stopped when stream.write return false. So here break it, and we have resumed the inside the drain event. So again we have called inside the drain event, and we have called the stream.end on your last write. Okay, so stream.end event, and we have used the finish event when the stream.end is called. So to clean up and benchmark we added, and also we have monitored the memory and optimized the thing. So that's it guys about this one. So how we have efficiently used the memory, and how we have efficiently written the huge file size without utilizing the most of the resources and Node.js, and we have seen it. So hope you understood about this one. So now you got a solid understanding about the writable streams and all those things. So don't forget to subscribe. That's it guys about this one. So if you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you.